वेलकम टू गॉड से भी हैप्पी। और आज हम देखेंगे डिफरेंशिएशन, जिसको हम डेरिवेटिव भी कहते हैं। तो डिफरेंशिएशन हमारा लिमिट से बहुत एसोसिएटेड होता है। हम हमारे पास डिफरेंशिएशन निकालने का फॉर्मूला होता है, फॉर्मूला जिसको हम कहते हैं फर्स्ट प्रिंसिपल मेथड। फर्स्ट प्रिंसिपल मेथड से हम अपना डिफरेंशिएशन निकालते हैं। तो वो हमारा रहता है एफ एक्स माइनस एच fx minus fx plus h minus fx upon h, and limit h tends to 0. This is our first principle method. In this is told in limit that this represents tends to. This means tends to. Now, using this formula, we can find the derivative of various uh, questions, and there are certain derivatives which are pre-given to us that we should learn to use them in other questions. For example, derivative of cos x is minus sin x. We will prove this, but this should be learned to us. Let's see the proof of this. Now, cos x equals fx, and cos x plus h equals fx plus h. Now, it's very simple to prove. Now, this is fx, this is fx plus h, this is fx, fx plus h, and this is fx. So, we will put them in the first principle method, and you can also consider it as a question to find the derivative using first principle method. So let's see, and after this I will also give you certain tricks to do the derivatives. So let's proceed with this question. Now, what was the formula? Fx plus h minus fx upon h, where limit h tends to 0. Now, fx plus h is cos x plus h minus cos x upon h, limit h tends 0. So, now, using trigonometry c plus d by 2 formula, we will solve this trigonometry, or we will simplify this trigonometry. So, 2 sine x plus h plus x by 2 sine x plus h minus x by 2 upon h, limit h tends to 0. Always remember to write limit. So now this x will be cancelled from here, and will be left with limit h tending to 0, h tending to 0, and 2 sine 2x plus h by 2 sine h by 2 sin h by 2 and upon h. So now, as you can see that this 2 this 2 can come in denominator. It is like a by b upon c by d equals a by b into d by c. Hope you understand. So limit limit h tending to 0, sine 2x plus h by 2 sine h by 2 upon h and put minus over here. In the trigonometric formula, it is minus 2 sine x c plus d by 2 and sine c minus d by 2. So what we'll do now is that we divide by 2. So using the limit property, we can see that this will become 1 as sine x upon x is 1. So limit we are now using the limit, and as we'll apply the limit 0, this will be sine x. So we can get the derivative as minus sine x, as h will be 0 and 2x by 2 will be cancelled, and we are left with minus sine x as the derivative. So now this was the derivative which we have proved through first principle method. Now there are certain derivatives that we should learn, like this one. Now to proceed further, let us remember, or let us recognize some concepts of limit, some properties of limit. So property of limit. So first property of limit that we had learned is limit extending to a and xn minus an upon x minus a is equal to n minus 1. Now this is the first, and second that we had learned is that limit extending to 0 sine x by x equals 0, and similar for tan x also. Sorry, it is 1. It is 1. It is 1. And now limit extending to 0 and a to the power x minus 1 upon x, where x is not equal to 0. This is very important, where x is not equal to 0, equals log e log base EA. And where a is greater than 0. This you would have learned in log also. And now we have limit extending to 0 e to the power x minus 1 upon x equals 1, and final that we have is limit extending to 0 log e 1 plus x upon x equals 1. These are few important limits that are very useful in limit, that are very useful in derivative differentiation. Differentiation useful, that very useful it is. Now let's learn some derivative that we should learn. We also represent derivative by d upon dx. Here function of dx is there, and we differentiate always with similar, like x over here and x over here. So the important derivative is that first one, x to the power n is equals n xn minus 1. Second, e to the power x derivative d e to the power x upon dx equals ex upon dx. Now, second that we have d8x upon dx equals log 1 upon x log EA. And do you know what is E over here? This is Napier's constant and its value is approximately 2.17. 2.17 its value. Okay. And now another that we have is log d log ex by dx. It is equal to 1 by x. And now we have the derivative of certain. Here log, it is this one is of log a log ax. And trigo. Now certain trigonometric derivatives. Trigo. Now, as we have proved that the cos x is minus sin x and sin x is cos x, derivative of sin x is cos x, and tan x equals sec square x, sec square x, and cot x equals minus cosec square x, and cosec x equals minus cosec x, and cot x, and sec x equals sec x tan x. Tan x. Now, from these, let's take this one and prove its derivative. Okay, so we shall proof derivative of this. So e to the power x. Now we should prove this with first principle method. First principle method we should use. Like write FP. Now we have fx is equals e to the power x, and fx plus h equals e x plus h. Now according to first principle formula, we have e to the power x plus h minus ex, limit h tends to 0, upon h equals limit h tending to 0. From this we can take ex common as it is in multiplication. So ex. Now e to the power h minus 1 upon h. Now we have seen that this is equals to 1 above. Let's recall it from above. So e to the power x minus 1 upon x equals 1. So let's apply this. So ex is the derivative and hence proved. Hence proved. And now you should be well learned with those formulas to solve the trigonometry. Now I will also, let's do one more question using first principle. Question: let's do the derivative of 1 upon x square. So we will do it like this: fx equals x plus h, fx equal to x of 1 upon x square, fx equal to 1 upon x square, and fx plus h equals 1 upon x plus h square. So what we will do now, that fx plus h minus x upon h, limit h tending to 0. Let's apply this. So 1 upon x plus h whole square minus 1 upon x square upon h, where limit is tending to 0. Limit h tending to 0. So let's solve this. Limit h tending to 0. Limit h tending to 0. And first let's open this bracket. So 1 upon x square plus h square plus 2xh minus 1 upon x square divided by h equals limit h tending to 0 equals x square minus x square minus h square, I'm taking LCM, minus 2xh upon x square plus h square plus 2xh bracket x square and h, this of 1 upon and will be multiplied over here. Now we can see that x and x cancelled. Now from these two we will take h common. So limit h tending to 0 minus h plus 2x upon x square plus h square plus 2x x square h or h cancel. Now applying limit, so 2x upon x square upon x square equals minus, so x cancel, so 2 upon x cube minus 2 upon x cube is the derivative of this. It is very simple. Hope you understand. And here we end our differentiation or derivative.